Okay. Bismillah ar-Rahman ar-Rahim. Just as a quick introduction to the, I think I did not charge. Just as a quick introduction to the course, of course, my name is Anwar Muhammad, for those of you who don't know me. I'm associate professor in the department since 2007, and I received my PhD in 2006 from University of British Columbia in Canada. So inshallah, at the beginning we'll go through the syllabus, and the syllabus is just the contract between the instructor and the students. So you need to seal the contract and agree on everything, all the terms and conditions in the syllabus before we move on. Okay. At the beginning, these are the office hours. So the office hours are Sundays or Tuesdays. So since you are the first lecture, you get to choose whether you prefer Sundays or Tuesdays, because since I'm teaching both girls and boys, I'm going to have to divide the office hours between the two. So either you prefer Sundays, which means I have to come here every Sunday at 11, or if you choose Tuesdays, in which case I'll do the same. But the other day is going to be for the boys. Okay? So that's one thing we have to agree on. And you have to tell me that before the end of the lecture. The other thing is the TA. It's not decided yet. So I asked Dr. Al and he said that this should be assigned sometime this week, hopefully. Okay. This is the course description. So basically, the course is an introduction to computer networks. So it provides the basics and fundamentals for computer networks. And we're going to go through the protocol model or the stack of the networks, and we're going to go through each layer, get some idea about some of the protocols and techniques in each layer. At the end of the course, you should be able to identify, recognize latest technologies related to computer networks. You should be able to compare technologies together. You should be able to work in groups through the lab on a project that involves some network design and so on. So these are the prerequisites. Okay, so the textbook is actually easy. The first thing is that I posted on Blackboard the CCNA material, and this is the main source of information for this course. You are welcome to buy the book, to buy the textbook, which is the Introduction to Networks version 5 course material from that's provided by Cisco. However, the online material, if you go to the course content on Blackboard, you will find the instructions on how to download the material. Don't try that just yet, because I asked Bishmas Muhammad to upload the material on the server so that when you execute the instructions, you'll be able to download it. So by the end of this week, it should be there. Of course, there are some other references as well. So you can, if you have this book, it might be useful. If you don't get some of the techniques from the lecture, you might get more details about these techniques from this textbook. However, as I said, the main source of material is the online material. Okay. These are the course objectives. Introduction to various network reference and layered models. So we'll talk about what network layer model is. We'll talk about some of the very key protocols and techniques like IP version 4, IP version 6, UDP, TCP, and some other protocols as well. We'll talk about the network access layers and what they how they work. We'll talk about routing and subnetting, and that's one of the most important parts of the lecture. So that's an ABIT thing. This is just to map the course objectives to program outcomes and stuff. It's an ABIT thing. These are the topics. So and how they are mapped to the weeks. So we're supposed to cover the exploring the network part this week, in addition to the course introduction, which we're doing now. And then later on, we're going to cover the different layers as we move forward. That's the key thing. Okay, so actually, this is okay. So regarding the assessment, I'm going to talk. This year, we have actually changed the assessment significantly. We have done so many changes, which I will talk about. Okay. So first, we're going to have 2 assignments, like last year. We're going to have 2 assignments, and the assignments will be 15%. We're going to have 2 midterms instead of 1, like we used to do last year, and each one is going to be 20%, so the total is 40. Quizzes, okay. So we have 10 quizzes, which means that roughly we have almost every week. We have, but the quiz is like very short, and I'm gonna tell you why I have so many quizzes which are very, very short. Okay, so every quiz is like 5 minutes, most. So you're gonna have like 3, 4 small questions, and that's it. I'm gonna have to talk about why I did that. That's totally different from what we did last year. Okay, and then the final, which I'm restricted to put it maximum 30% as per the university policy. Okay, so that's pretty much it regarding the syllabus. So the other is just some other anything, like just dummy things. So this year, as I said, this year we have so many changes. Okay, the reason is in the last couple of years we've been teaching the course from the Cisco material of CCNA 1 version 4. Even though the version 5 has been released. We had so many complaints from students, and we had so many issues actually teaching the course, because the Cisco Academy, they teach version 5.1, all the material online and everything is 5.1, and we teach version 4. Students don't get to do the exam at the end, which is one of the best advantages that students actually enjoyed in previous years and so on. But we had to get so many approvals from the curriculum committee and so on. So what triggered this is that so many complaints from the students, especially last year, that they couldn't do the online exam at the end, and I'm going to talk about this online exam. So we needed to change the course material. So we switched to course material version 5.1. That has some implications. That's good and bad at the same time. It's good because it actually touches on many state-of-the-art which we have nowadays, rather than just teaching some obsolete material and some very old devices which are not being used anymore. So now we teach like some recent stuff. We teach IP version 6. There is a significant part in that course regarding IP version 6. We show you like cloud computing, and we go through some of the immersion techniques and so on. The bad thing, of course, is that students have to be aware that there are some significant parts of the course which are brand new this year. That actually triggered myself to change the teaching method of the course. Since we are starting almost from scratch, I thought we can introduce some of the new teaching methods. And I'm not sure how many of you is familiar with the flipped classes. Have you heard about flipped classes before?
No.
So flipped classes basically means that you're going to have to get yourself familiar with the material before the class. Okay? And try to make that as enjoyable as possible, that I'm actually recording all the lectures on YouTube. And I used to do that, but I used to do that during the lecture itself. But now I have to do it offline and give you access to all the recordings of the lectures before before the lecture. So the sequence is as follows. So every week we have about 3 clips, 3 video clips. Each of them is around 20 minutes. So I will do my best not to make it more than 1 hour. Okay, so before Sunday, you need to watch the 3 clips. So during the week, you need to watch the 3 clips. Okay, and just at your free time, just watch it on your cell phone, on your laptop, on your tablet, anything. And you're supposed to get at least 50% or something like that from the material. Just be aware of what's going on. On Sunday, of course, I have to have some means to enforce that or to encourage you or to motivate you to watch the video, and that's why we have these frequent quizzes. On Sunday, we have a quick quiz, like 5-10 minutes, and I'll try to do it even online on Blackboard. So you have like some multiple choice questions, or just identify some term that you have watched on the video and so on, just to make sure that you have actually watched the video. Okay.
والكويز قبل الكلاس ولا بعد الكلاس؟
الكويز قبل الكلاس. Okay. Now we have to make sure that you have actually watched the videos. After the class, we will have gone through the concepts already. So and again, we'll do that anyway. And I will, you will really see the benefit of this. That in the past, it used to be like one-way communication. So the instructor would just dump the material to the students, and that's the traditional way. So now with this, you have some chance to absorb, part of the material before you get to the lecture. And in the lecture, we're going to have some interaction, more in-depth discussion. And that's the main objective of this. So you're going to have to work in pairs. And I will give you some like small activities or exercises during the class. I will see how you progress in this activity, and then we'll explain things. The activity is not to check you. It's not an exam. It's just to facilitate some interaction between the instructor and the different groups. And through this interaction, we'll understand more in depth some of the techniques. Because, in the past, I used to explain things and I used to repeat things. And at the end, I get the feeling that everyone got everything. But when it comes to the exams, when it comes to exams, I realize that this is not the case. So what we will try to do this year differently is that we'll try to have constant interaction during the class through activities and through some in-depth discussions. Of course, some of the techniques will be hard. You will not be able to get it from the first time, in which case I will do the exact same thing that we're doing now, and I will explain things on the board. We will even record the lecture if needed, and then we'll put it with the video recording on YouTube. So at the end, you can have a set of videos that you can refer to at any point in time, and we'll be able to reuse these videos amongst the groups. We'll be able to, if there is something that's very hard on all groups, I'm going to have to record it offline and go through some exercises offline and then post it on YouTube, just make sure that all the groups, they got the same concept.
So just to make things clear, now we will have a quiz on the materials that will be discussed during the week.
The week, yes.
Like the pre-class.
Yes, right. So as I said, every week we're going to have at most 3 clips. And the total of these 3 clips is not going to be more than 1 hour. I'll do my best not to make it more than 1 hour. There is actually even a trick on YouTube that you can increase the time of the play. Yeah. If you know that, then you can reduce the time potentially to 45 minutes. So you can save some time. And in the recording, I tend to speak very slowly. So if you do that, you will it will be fine. Okay. So as I said, I was debating with myself whether I go through in the video recording, I go through the presentations or I go through the online material. And I did so many investigations actually in the last couple of weeks, and I realized that the online material contains, after I actually prepared all the presentations for all the lectures, I realized that the online material contains some videos and animations which I cannot actually copy on the presentations. So at the end, I decided to just go to the online material, open it, and just go through it. And actually, you will see that the videos. I did some significant effort to produce these videos. I hope you actually appreciate that, and I hope it benefits you. And during the lecture, we will go more in depth through the material. Okay. Of course, I highly encourage people to participate during the class. So the interaction is going to increase that, but I need the students to be more proactive in terms of asking questions, triggering myself to just explain things more deeply and so on, and work on the activities. You need to have a pen and just a paper. That's it. And the exams or the quizzes, you can do it on your cell phone, you can do it on laptop, and I know what happens with the cell phones and these things. So I'm gonna have to work around that and just make sure that nothing weird is gonna happen. And if we discover something, we'll deal with it. Okay. So one thing that's very important is that I don't expect you to know something that we don't go through in class. So even if something in the online material, which we did not cover, we just skipped, this means that you don't have to go through it. Okay? Because the material is very condensed. So sometimes I skip some little parts here and there because I know that they are not important, or I know that in order for you to get the idea of this, you need to I need to explain some techniques and some concepts which is not part of the course. So it would be very hard for you to understand what's going on without me actually explaining these concepts. On the other side, if we explain something in class and it's not in the online material, I also expect you to know it. Okay. And at the end, like supposedly there is no surprise test. So all the questions are going to be from the lectures and from the videos. There's nothing that's outside of this video. So these are the instructions how to download the material. It's basically, we'll upload it on the Cisco website, on the Cisco Regional Academy website. I know that you are all familiar with Cisco Regional Academy, which is part of the College of Engineering. And the website is there, so you can just get to the link and download the material. As I said, don't do that just yet. Do it by the end of this week. Hopefully we will have the material uploaded. What I tried to do in previous years is that I tried to upload the material on Blackboard, but it tends to be very large, so Blackboard just rejected. So maybe what I will do this year is that I'll do the same. I'll try again, and if I have time, I will contact ITS, which usually I get to a dead end and I do things my own way. So I will see. But hopefully by the end of this week, the material will be available. Okay. And just be aware that you need to download Firefox because the material does not work on any other browser. Okay. Type office hours, as I said, you didn't tell me so far whether you prefer Sundays or Tuesday. If I don't get any information from you, I'm going to have to pick anything and go with it. Okay?
Tuesday? Yes.
Okay, so Tuesday it is. Okay.
Does it have to be from 11 to 12?
Well, so these are the alternatives. So if the time does not suit you, what will happen is that you're going to have to do some appointments. For girls, it's going to be tricky because we've been discouraged from the college to meet, to have the girls to come to the male campus, and unfortunately my office in the male campus, and that's why I tried to make some alternatives. So you can send your questions by email, you can post your questions on a discussion board which I have created for the course. There is a general discussion board, so feel free to post your questions there. And at the end, that's the office hour, which officially I'm going to have to come here and wait for all your questions. And outside of this, I'm going to be in my office, and hopefully I'm going to be receiving your questions through these alternatives. Any questions? Okay. So if no questions, we'll just go briefly through like some of the few slides of the first chapter. We're going to have to hopefully finish these slides. So what will happen is that, of course, in the first week, I don't have videos for you, and of course, you don't know about all these new changes. So in the first week, we're going to have to record the lectures in the traditional way. Well, actually, in the traditional way, we didn't have to even record the lectures, but so we'll record the lectures for this week. Okay, so starting from Sunday, next week, Sunday, so we're going to start with a quick quiz at the beginning, and then we'll go through the material as we have discussed. Okay, any questions before we start? So basically, this is just a brief introduction, and the first chapter is not that important. It's just to motivate. Well, it is important in a way that it motivates the students why this topic is very important. We will go roughly through some of the emerging technologies and stuff, but the purpose is not to go through these technologies deeply or to understand how they work and stuff. It's just that we try to tell you that all these technologies, they use computer networks one way or another, in which case the topic is actually important. So that's the purpose of this chapter. So computer networks, they make people around the world, they make computers around the world globally connected. We know that the internet is a group of LANs and WANs, so we're going to go through what is the definition of a LAN, what is the definition of WAN, and how is the network actually designed, what are the bits and pieces of the network, the network as a platform, and how we can change the network environment to tweak for our needs, like how we configure the network in such a way that works as a data center or work for cloud computing and so on and so forth. Again, we're not going to go deeply through any of these. It's just scratching the surface just to give you some motivation that this topic is important. So as we all know, the trend for the number of devices across the internet is actually doubling every few years. So people are expecting that by 2020 that the number of things, and by things here we don't mean just laptops, we don't mean just cell phones, we mean anything. Your clothing is going to be connected to the internet. Your fridge at home is going to be connected to the internet. This pen is going to be connected to the internet. Everything on earth, this table, your bag is going to be connected to the internet. So they are expecting the number of things that will be connected to the internet is going to be around 50 billion things. Okay, so you can imagine the type of network that can connect these things together, and how scalable and how wide and how large it could be. So the trend is actually increasing. So so nowadays we started to do everything on the network. So this is like a telepresence meeting that people are meeting each other, but some of them are remote in like some places, and they are connected as if they are on the round table. They can even shake hands and stuff on this round table to give you the indication that this is a real meeting between people in this room. And of course, this will not happen if we don't have a very fast and very reliable network in the background that can connect these people together. So many of these applications have actually come about, and they have become a reality because of the networks. So networks support the way we learn. So we have Blackboard, we have all these fancy tools that helps us to learn. Networks support the way we communicate, the way we work, the way we play, even games and stuff. As we see now, kids are playing over the network. Each one has an account, and they can connect and play games together. So, so we can imagine the amount of sophistication and complexity in these networks to be able to support these different applications. And in this course, we will actually realize that these applications, they have totally different characteristics. Some of these applications are very much, poor in terms of bandwidth, in terms of data rates, and some other applications are very high in terms of demand for bit rates. So the network has to tweak itself, and how it has to tailor the resources to fulfill the demands of all these applications altogether. So networks, they tend to have different sizes. We can have a network in a small home. We can have a network in an office. We can have a network in a building. We can have a network in a city. So how we evolve the network from a small house to an office which has like different rooms, to a building which has different floors, to a city, to a whole city which is a group of buildings. So we can imagine, in order to connect these things together, there are some characteristics and some limitations and some design issues that we have to go through. So in a small house, for example, in a small house, the cables are very short and everything works fine. Or maybe we use wireless in some cases because of the luxury, but we can connect things using wires, small wires, short wires. There's no problem. In small office, however, things tend to be a little bit larger, so we need to design for that. In large buildings, we have even different floors. So how are we going to connect wires? Or are we going to use wireless, in which case the ceilings and stuff are going to block the way. So many issues they come in place. If we talk about cities, big cities, then connecting these things is going to be very hard. So maybe you need someone like Ooredoo in the middle that provides long-range communication, provides some network resources for you to connect to these buildings through the internet. So on a high level, our networks are divided into clients and servers, and maybe we're familiar with these terms. We use it a lot, but maybe we don't really understand what it means. So a client is the entity that always initiates the communication. A client is the entity that requests or demands something, and the server is the entity that receives these requests and fulfills these requests. So if you have a client and a server, your browser, for example, is just an example of a client. When you say google.com, what you actually do is that you make a request to the Google server, and then you get the web page. So that's an example, a simple example of a client and a server. And these things are just software. So your laptop can have some applications that work as a client, and some other applications that work as a server. So you can have a group of servers and clients at the same time. And by having these different machines, whether these are clients or servers, they can communicate through some requests and some replies for these requests. So our email server in the ITS is another example. So all our emails are hosted on ITS email server. And when we open any email client, we request our emails, and then we go through it one by one. So that's an example of email server and email clients. Of course, there are different characteristics for a server versus a client. Client is actually does not serve anyone else but itself. So it requests the demand from the server. But the server receives many requests from many clients. So it needs to it needs to be like heavy duty. It needs to have, it needs to connect to many clients at the same time. It needs to be able to process many requests at the same time. So you have to have like a bigger machine or a faster machine and so on in order to work as a server. Versus the client is actually very lightweight. Peer-to-peer on the other side is another architecture that's used over the internet. And by peer-to-peer, we mean that each device or each application works as a client and a server at the same time. There's no actually centralized server and many clients. Okay? An example of this is BitTorrent or eMule or eDonkey or all this software. This works as peer-to-peer, which means that all of us are peers. I can serve your request and you can serve my request. Or I can serve your request and someone else can serve my request or something like this. So in other words, we have another like human network on top of the internet, okay, which logically represents how people are communicating. So for example, I wish I had the pen working, but I will try to do it like with my hand. So you have many clients like this. These are connected physically on their networks using different ways, which we're gonna talk about. So maybe the communication in peer-to-peer is that I work as a server for this guy, and then this guy requests something from this guy, and then this guy requests something from this guy, and so on. So each one of these is just an application, okay, like BitTorrent or something. So we're gonna have an overlay network on top of the internet, which allows us to get files or get some services from each other. So each of these applications works as a client and a server at the same time. It can serve someone, and at the same time, it can request someone to serve it. Okay? So that's the difference between peer-to-peer and a client server. A client server, the client never serves anyone but itself. The application itself works as a client, and that's it. So it's one direction. But here, we can have bi-directional communication between the different peers. Peer-to-peer has recently been invented, and it had like many potential benefits that people can communicate in a more efficient way, and they can serve each other. The thing is that always when you centralize things, you tend to have some limitation. So client-server tends to have this limitation by centralizing all the service to the server. Whereas peer-to-peer uses the power of people. So anyone can serve anyone. So you can imagine the amount of information that can flow between people by having this concept, peer-to-peer. So anyone can serve anyone. In a similar way, Facebook works using the same concept, but in a slightly different way. Like anybody can put a content on your web page or your Facebook page. Anyone, okay, anyone that you are friends to.
Yeah.
So this way, you can imagine the amount of content that can potentially come into your page, and you can look at it, and you can filter it, and you can get some information out of it. So that actually leverages the same concept, more or less. Okay. Okay. So quickly, we'll go through LANs and WANs. In order to form the network, we have to start with smaller components or smaller pieces. Okay. So first, we have to connect computers in this room, and then connect this room to another room, and then connect this building to another building. So we have to go gradually, and we call that a hierarchical architecture. Okay. So So the networks, they are composed of devices that they need to connect together, and media, or the content or the applications on on our computers, and services that we will talk about what is the difference between media or application and a service. So this is the hardware and software, okay, that we need to connect together. So our devices, like this device, has some content, some media, some services, and so on. And we need to connect this computer with other computers. So network provides to us some intermediate network devices that facilitates this communication. Okay. So for example, if I need to communicate with another computer here, like 1 meter away, we can like connect a cable and go through it. So there's no need. But the problem comes when we try to connect between this device and another device on another room, in which case we cannot dig a cable all the way. So we need something in between that facilitates this communication. And these are the network intermediate devices that we need to learn throughout this course. So for example, we need a switch. So we need a switch to connect multiple machines together. So this switch needs to connect to a router. Okay, and this router needs to connect to another router to inter-network multiple networks together. So connecting multiple of these computers using a switch is what we call a LAN. A LAN is a local area network. Okay. A local area network is a geographically small network that covers a small area. Okay, could be like a classroom or 2 classrooms that are geographically located close to each other. Okay. What you use in LANs is barely a switch or a hub. And this LAN is usually connected or terminated in one router. Okay? So each port on the router, as you will learn in the lab, each port on the router connects a LAN with another LAN. Okay? So we form a LAN by connecting switches and hubs. And we will learn in details how each of these actually works. And then we connect this LAN to a router. The router is just the termination of this LAN. Okay? When we connect this router to other routers, we enter a network, multiple LANs together in what we call a WAN, or a wide area network. So a wide area network can cover geographically a large area, like at least a building or multiple buildings together. The ultimate WAN is what is the internet. Okay, so the internet is just an inter-networking of millions and millions of LANs, small LANs. Okay, so that's the ultimate definition of the WAN. So we have end devices. By end devices here, we mean devices like this, this tablet, my cell phone, things like that. Okay, so these end devices, these are computers, these are phones, and so on, and security cameras. And as we said, the future actually carries many innovations when it comes to these end devices, whether it's our clothing, it's our pens, it's our fridge, and so on. So these are end devices. But these end devices, they are connected in the network through what we call network devices, like switches, wireless access points, like routers, firewalls. All these are network devices that facilitate our communication. Okay? So the network is just cabling end devices with network devices. That's it. But how we do that is just is a very complicated process that we will learn how to do. Okay. So I think we can stop here.